So thanks to Vectric for sponsoring me being here at Maker Central this weekend. So I'm actually on the Vectric booth with my ball-wheeled vehicle. So there we go. I'm also a trustee of Southampton Makerspace. So if you're in the south of England and you're looking for a not-for-profit community creative space, then there is a makerspace in Southampton, the best kept secret. It's our 10-year anniversary and people are still finding us. And we've got a CNC, and we use Vectric software. We use VCarve Makerspace Edition, courtesy of Vectric, which is very good for 2.5D. It's really easy to get started, so we have an in-person induction, and we show everyone how to use it. So there we go. I've decided to retitle the talk, Making It Bigger with CNC. So a lot of you probably know that I do a lot of 3D printing if you've seen my channel, but I also have a CNC and a welder. And in brackets, I just build it for clicks, because basically I'm a YouTuber and I have to make content people will watch, which is why there's a very strange bright red chair on balls, because that's the weirdest thing I could think of at the time. So I have an Avid CNC Benchtop Pro 2x2 machine, courtesy of Avid CNC, formerly CNC Router Parts in the US. And I use Vectric Aspire to do all my tool pathing, even though I use other CAD software to actually do the design. I am sponsored by Lulzbot 3D printers as well for all my 3D printing. But when I make things bigger, then there's a lot you can do with 3D printing and plywood and aluminium to make bigger things quicker than 3D printing them. So one of the first projects I did when I got my CNC was to build a robot dog, which is approximately, I think it's 800 millimeters long or something, and it's a 2-person lift. This was the first version of the robot dog. There isn't any footage of it walking because it didn't really work. It did kind of go along. It was a bit like an AT-AT, but less stable than that, even though it's got shorter legs. All the yellow is 3D printed, and all the aluminium is CNC'd, and it had aluminium extrusion in it, and it had 12 brushless motors, and it was very heavy. So I built about 7 robot dogs, including test logs and test legs. I'm pretty sure Boston Dynamics have got quite a few bits and pieces in their lab that you never see. So I think that's okay for someone in their back bedroom with a 3D printer and a CNC. I'm going to skip all the other versions, but basically this is OpenDog 3, which works a lot better. And you'll notice its legs are quite springy. There are no actual springs in it. Basically what we've got is a big brushless motor with a 10:1 reduction. And then there's an encoder on the motor and a controller that's trying to hold that joint in position. But you can back drive it because it's a low reduction. And the motor driver just applies more current and tries to put it back. So then it acts a bit like a spring, even though there's no springs. So it's quite dynamic. So you can kick it around and it can tread over wood and things like that. And hopefully nothing goes wrong. It's not too bad. So the reduction that I built is a cycloidal drive. So I wanted to make all of it 3D printable in PLA so that it can be reproduced. And the whole thing is published as open source as well if you want to make one. And I've tried to use open source hardware where I can. So instead of having 3D printed, say, a planetary gearbox with little gears that all break, I've got these discs, which, let me just play that again. There we go. So you can see it's like a wobble reduction with lots of metal bearings. I was going to CNC the discs out of aluminium or Delrin or something like that, but actually they work fine in PLA, so the whole thing can be made in PLA. But this is something I'd really like to scale up to make a massive one with CNC and make a giant walking robot. I've also got a bit of an obsession with doing one-wheel balancing robots. So you've probably seen something like a gyroscope or a spinning top. And there's a bit of a misconception that a spinning top will stand up on its own, and it will if it's free to move. But if you anchor one axis, then basically it won't stand up anymore. But if you move it in one axis, so in the roll axis, it'll automatically apply a force in the pitch axis, and this is called gyroscopic precession. So as you tilt it in one axis, the force is in the other axis. So a spinning top stands up because it constantly precesses, constantly falling and then moving in a perpendicular axis, which makes it move in a perpendicular axis. If you anchor one axis, that doesn't work anymore though. We can use this to our advantage by making a control moment gyroscope. So this is actively controlled in one axis with a servo that's on the right-hand side. There's a piece of electronics in the front, and that's measuring the angle of roll, and that's moving the gyro in pitch, which is the control axis, and that's applying a perpendicular force back in roll so it stands on its edge. And this is used commercially. There's a product called the Seakeeper, which is basically a bigger scale version of this for stabilizing boats and stopping them rolling. So that's a dynamic system. There's a PID controller. There's probably a whole talk on the control loop. But essentially, we have a control axis which exerts a force in a perpendicular axis, and that's very important. So the logical step to move on there was to build a two-wheel inline balancing robot. So this has the gyroscopes mounted vertically, and they rotate in the yaw axis, which is the control axis, and that causes a perpendicular force in roll, which holds it upright, responding to an inertial measurement unit measuring it again. So this is something, again, I'd like to scale up, and instead of having 3D printed gyroscopes with ball bearings in them, I want to use brake discs from cars, and then put it on a bicycle, so we can have a bicycle that stands on two wheels by itself, and is radio controlled and can steer and drive around and then stop and go backwards. I also moved on to make a one-wheel balancing robot using the same top and then having one wheel. And the one wheel balances like a Segway back to front or a hoverboard. And then side to side it's held up with the gyros. You'll notice it wanders away quite a lot, and that's because the gyros have the motor on the back, so as they tilt, it puts mass in one direction and it's like leaning, which is why it never stands still. We could fix that with another control loop. But all of these were one-week projects that I did on YouTube. So it proves the principle at least. This is a reaction wheel, which isn't a gyroscope, even though it spins. It turns in each direction around a central point which should be stationary, and the reaction of it spinning makes the robot fall in the other direction. So it's like if you have a heavy mass and you push it in one direction, it pushes you the other way, and it does that by spinning. So the logical step to move on there was another one-wheel balancing robot, which uses a reaction wheel side to side. The reaction wheel still has some gyroscopic force, remember, that makes a perpendicular force if it moves while it's in motion. So if the reaction wheel's spinning and it leans forward, then that causes it to turn, which was unexpected. Well, expected and unexpected. So that wasn't quite as good as the other one. The reaction wheel is quite an important thing, because that is one of the things I have scaled up, and I'll show you the project shortly. I also really like Omni Wheels in my channel. So an Omni Wheel is a wheel which has lots of little wheels around the outside. So you can drive it like a normal wheel, and it'll roll along. So if you put 3 of those in a 120-degree configuration, then you can vector the velocities, and you can move in any direction. So you can move directly sideways, and you can move front to back. And you can also rotate on the spot by adding a bit to all of them in the same direction. This isn't my project, these are stock images. But liking one-wheel balancing robots, I decided to make an Omni wheel, basically, with little wheels all around the outside, but make it balance on that Omni wheel. And the only way to really do that is to be able to drive the little wheels. So every one of those wheels has a 90-degree twisted belt that goes to another sprocket in the middle of the wheel, and in the middle of that's an even bigger sprocket, so that we can drive the little wheels all together in one direction. So with some bearings and things to hold that in the middle, and installing another pulley, we can drive all of the little wheels. So basically there's a pulley on the main wheel attached to the body, which will drive it like a normal wheel. And then there's another one on the other side, there's a differential drive, and when you turn that against the wheel, then it causes all of the little wheels to turn. So driving both of them together will give you a wheel, and then driving one against the other will make all the little wheels turn so it can go sideways. So basically that means then using 2 motors, an inertial measurement unit with 2 axes to measure where it's falling, we can make something that balances on one wheel. So it's like a Segway or a hoverboard, but it balances back to front and side to side. There's a slight problem with this though, because the little wheels are tapered to match the circumference of the big wheel, which means that at some point the diameter's bigger in the middle and it's smaller on the outside of them, which means the velocity varies depending on the position in the other axis And so it's very hard to tune, and sometimes there's not enough velocity to catch itself to make it balance, so it just runs away with itself. And there's not an easy way of improving that other than making the wheels flat cylinders, but then obviously it would kind of get stuck rolling the other way. Or it would probably settle actually, but then you wouldn't be able to tune it to balance properly. It's a fine balancing act. And this is another type of Omni wheel. So instead of having a wheel with passive little wheels around the outside, what we've got is some hemispheres. So this concept I didn't actually come up with. It's from Osaka University in Japan. There's a video on YouTube. So we've got, instead of the passive wheels around the outside of a big wheel, we've got hemispheres that are free to rotate. So this is my version that I did, which was the small version. So we can drive it actively on the axle back to front, but then the hemispheres spin freely, so it'll freewheel in the other direction. The only thing that happens is when you're on the peak of the hemisphere, they can't rotate anymore, so we need the little wheel so it can still slide when it's on the peak of the hemisphere, which is kind of the weak point because there's not very much clearance. But putting 3 of those in a 120-degree configuration, we can make an omnidirectional robot. So it can spin by spinning them all in the same direction, and it can also move in all directions by altering the velocities of those wheels with a little bit of trigonometry to work out the 60 or 120 degrees and working out the velocities. So I'm controlling this with a joystick which pushes forward and back and left and right and also rotates to do the rotation motion. I've done quite a lot of other projects as well because I've done weekly videos for 10 years. So I've done quite a lot of collaborations, including with Colin Furze, who's here today, and Mark Rober, who asked me to help him with an auto-strike bowling ball, which he wanted to be able to always win at bowling. So this is my auto-strike bowling ball internals, which has CNC parts in as well as 3D printing, because it had to be quite compact. We needed to mount the servo and things, so it was strongly fixed in there. Obviously, it's quite a lot of force on a bowling ball when it hits the pins. Mark had bowling balls made, which he had hollowed out in a machine shop in Wisconsin, but the majority of them shattered when, if you take the insides of a bowling ball out, there's not much to the shell. So we had quite a few, and he came over. This is in Southampton. Mark came over to my house, and he brought a bag full of bowling balls that had been hollowed out, and then we went to a bowling alley. So yeah, he basically is an inertial measurement unit on his back and a radio link, and then there's a pendulum that swings, and that causes the bowling ball to steer wherever you want. So you can always score a strike, but you'll notice someone down the other end there catching it because we didn't want to shatter it before it was ready. But he was pretty happy with that. I think the video's had 50 million views in his channel or something. So I said I was going to talk about making it bigger with CNC. So at the start of last summer, I rented 1,000 square foot of workshop space. And I've had a CNC machine for a while, well before the pandemic, and I've had a welder, courtesy of Lincoln Electric, for a while, and Ryobi tools, and lots of other things. So I thought I'd do some of these projects I've really wanted to think about doing, making some of these small robots and things, making them bigger. So here we go. The first project that I thought I'd do in there was the Omniwheel Bicycle. So here's my CAD. That's actually in Fusion 360. But then this is Vectric Aspire. So this is doing all the tool pathing for the wheel. The most accessible material, really, I thought would be wood, which is a good choice. I mean, you could use Delrin or nylon, but it's quite expensive, right? Whereas you can go down to Wix and get some plywood. So there we go. I actually had to cut quite accurate 6mm slots in this. And all my wood down cutting bits were imperial, so they're bigger than 6mm. So I had to use a metal up cutter, mainly because I did weekly videos at the time and I didn't have time to get any cutters that I should have used. Anyway, so basically it's got these spokes, and then it's got skateboard wheels all around the outside of it. I also CNC'd out the gearbox parts, which are hybrid 3D print and aluminium. So again, that's toolpathed in Aspire, and then CNC'd out on my machine. And here it is. So it's a balancing robot, sort of. It balances side to side, a bit like a Segway or a hoverboard when you lean. But also, because of the little wheels all around the big wheel, that means it can passively slide forwards, which means that you can ride it like a normal bike. And you can turn on and off the balancing. So for anyone knows about PID controllers, that's the integral wind-up when I turned it on. But otherwise, it's a lot of fun. So the idea is you can ride up and then spin round on the spot and then ride away in the other direction. My strategy of making it bigger worked here because this video did about 3 million views, which is about 30 times the average view count at the time. So then I thought that wasn't very fast and furious. Let's put the wheel on a go-kart. So this has got 10-inch hoverboard wheels on the front with 2 skateboard controllers. So I've got a foot pedal to accelerate. And then on my handset, I've got little thumb sticks from e-bikes, like the little twist grip things from the accelerator. And that drives the gearbox, which is really similar to the other bike, CNC'd aluminium plates and 3D prints, 2-stage belt reduction. So you can control the drift by spinning that wheel round in either direction, which is, it's a bit unstable at the back because of the one wheel. I think I cut out all the footage of this of me crashing upside down and the steering wheel digging me in the guts. But yeah, it was a lot of fun. For some reason, the video didn't do that well, but I enjoyed it more than the bike. And the other thing you can do on this is drift backwards, which you can't do on a normal drift kart, as far as I know. Yeah, so I did this small ball wheel vehicle with the ball wheels, the 3 Omni wheels, and all the comments on YouTube said, make one you can ride on. So a year later, after I got my workshop, that was the next project, which is what's over here for those of you who haven't seen it. So again, I used Vectric Aspire to toolpath the wheels. So I couldn't really think of how I was going to make hemispheres. You could make a hollow dome or something out of fiberglass, but really setting bearings in it is going to be quite tricky. It's going to need some internal structure. So I just decided to make them out of wood. So the whole thing slots together like one of those laser cut kits of a dinosaur or something. And it's all glued and screwed together. There we go. To make the hemispheres. And of course I had to make 6 of these because I need 3 wheels and each one's got 2 hemispheres. Nonetheless though, this was 1-week project to make all the wheels, and then the next week I made the rest of it. So there you go. I often go to universities and I talk to students, and the lecturers always say the students think that deadlines are too tight and the assignments are too hard. And I tell them how I do 1-week video projects, and all the air gets sucked out of the room by the gasps. And then I took it to EMF camp, which was a electromagnetic field. It's a sort of camping festival. It's a bit like this, but a camping festival with crazy creative people and giant walking robots and ball-wheeled vehicles. So I wasn't sure what was going to happen to the little wheels when I drove it on grass, but actually if you drive sideways everywhere, as well as getting more traction because all the wheels are spinning, also the little wheels, the red wheels in the end, don't touch the ground very much, so they just kind of skip by and everything's fine. So a bit of grass got stuck in them, but on the whole it actually worked really well off-road. And the motors are 1500 watts each, so there's plenty of power. I mentioned reaction wheels earlier. So if you watch Colin's channel, you'll notice that generally he puts himself in the project, right? He's building a funny bike or a tunnel. So I thought this Omniwheel balancing bike did really well with me on it, so let's do something else that I get in or put on myself. So I decided that maybe I'd put a reaction wheel on my back and see if it'd help me balance. So you'll notice the gearbox looks really similar to the other projects because it's basically a copy and paste in CAD. So another 2-stage belt reduction, which was CNC'd out of aluminium. And then the sticks sticking out are more and more steel that I had to add on it to get enough mass. So it ended up weighing about 30 kilograms. It's on a frame rucksack. And there we go, but it did sort of work. I was going to scrap the project. The morning I shot this and got it working, I was about to scrap the project and just say this is never going to work. And then I managed to actually work out what to do, which is as you walk, you have to imagine people pushing you each side. So as you take a step one way, you have to like push off it and push back the other way. If you push in one direction for too long, there isn't enough mass in there or enough reaction to actually balance you. But yeah, we did actually get it to work in the end, so I was quite happy with that. And that did 1 million views, so there you go. If you want to do well on YouTube, do a crazy thing that you wear with a spinning wheel of death on. So what's coming up on that note? Tuesday's video is a crash test dummy, which is made of CNC plywood, 3D printing, welded steel, and it's also got Lego in it. But you'll have to watch the video to find out where the Lego is. It's got 2 accelerometers in it that can measure G-force, one in the head and one in the body. And that means I can measure whiplash between the head and the body as well. And it's got 2 load cells in the rib cage, which means that I can measure up to 100 kilograms of force on the ribs. All of the joints dislocate, and it's got other hidden features. And to test it, I did check what happens when it falls to see if the accelerometers go weightless, and they do. So you'll have to watch that on Tuesday. 2 weeks, I'm quite ahead with content, you see, good planning here, so I do it. So the 2 weeks ahead, Tuesday, 2 weeks, is can you ride a bike with a caster wheel on the back? So it's got an 8-inch caster wheel on the back of it, and on the front is a 1 kilowatt e-bike wheel. It's a scooter so I can jump off because it's quite sketchy, and I didn't want my legs trapped either side of the frame, because I've done a bike like that before with 2 servo steering on the back, and every time you fall off, the frame whacks you in the leg. So yeah, so will it work? Will it just slip out from under me? Will I be able to drift? The answer to all of those is yes and no. So yes, I'm youtube.com/James Bruton, that's Bruton, not any other variant. And everywhere else, I'm XRobots UK on social media. Right, that's all I've got. Have we got any questions?
Yes, I have a question. So was there any, did you ever had a mechanism that you completely had to invent? A thing that there was no concept yet and you had to come up with the whole thing?
I mostly steal ideas from other YouTube videos. So I think, well, so the video I put out last week was a tentacle robot. There's 3 stages, but it's basically 3 Stewart platforms, which is a 6-axis platform that has 6 actuators, and it can move all around. So I just put 3 of those on top of each other. But I haven't seen anyone else do that before. But obviously the Stewart platform I didn't invent. So I basically get ideas and repurpose them. Most projects are like that.
For the wooden balls on the chair, did you then recreate it in plastic, which is what we're seeing?
Oh no, they're actually wooden on there. They've just got some edging strip on them, so I painted them all silver with acrylic paint, and then I put edging strip on so the wood didn't get all bashed up. Apart from on the very peak of the hemisphere, you can't put the edging on, because as it kind of slopes over, the edging would cut through the discs, because it goes over. So that's why the edges are bald, and they're all smashed up. So I need to chisel all that off and put some sort of aluminium cap or something on that's much stronger. But yeah, they're actually wood.
You mentioned PID loops a couple of times,
yeah.
And I've done various things with trying to get into PID loops, and all the videos I've seen are always confusing as hell and really boring. Have you got any ideas of good places to look for interesting and informative PID loop videos, please?
It's a difficult one because it depends what you're trying to achieve. Is it a balancing robot or something else?
Just motors in general, motor control and
okay.
smoothing stuff out. Yeah.
If it's just motor position control, you probably don't need the I term. You could probably just have proportional and a bit of derivative. If it's a balancing robot, then you want a very high integral term. It's the basic advice, but I just work this out by doing it. So it depends on the system. There's no real simple use case.
Can you do us a video?
That's the sort of video that my Discord members want, like in-depth tutorials, but it's a sort of video that does really badly because it's not like if you only want to know it if you want to know it. Most people want to see, I don't know, a snake walking in an exoskeleton or something, so those videos do well and anything else does badly, so probably not, unfortunately.
Would you say you work more hours now than you did in a real job, or less?
About the same. I try and stick to business hours now. I mean, if I've got nothing to do on a Saturday and I can catch up, I will, but most of the time I try to just do work Monday to Friday, 9 to 5, and that's it.
So most of my projects don't really, as in, take months or years to finish. You seem to do it one every week. How do you manage your time with that?
Yeah, so I did weekly for 10 years, but actually since last August I dropped back to every 2 weeks. Most people still say, how do you do videos weekly? So apparently no one noticed. But yeah, a lot of planning. So I've got the videos done. I've started the one for the end of June right now. So just making sure I bought parts in time. I know what I'm doing. I know it's within my capabilities. I don't get too many new components or new methods in a project at once. I maybe one, but I've already found out that module or component works so that I can do the project and I'm not stuck having to try and find another solution or buy something else. It's just a lot of forward planning. And apart from that, I do everything myself, so.
You mentioned, you casually mentioned that you almost had to scrap an entire project. I was just wondering if there were any other projects that you had to scrap that you wish you didn't have to.
I don't think there are. I've had things that haven't worked the way they should, and generally, if I've already made quite a lot of video and I've tried different iterations, then I just say, well, you know, it didn't work, I think I need to do this, we'll come back and do a version 2. Or it's not as good as it should be. But generally, I don't scrap whole projects. That would be the exception, because if it didn't work at all, then what do? You say, you just like, there's no conclusion, you know, and if it can't be made to work, because you need so much mass you can't carry it, then, you know.
What was the best project you did, and then what was the hardest project you did?
I didn't catch that, sorry.
What was the best project you did?
Okay.
And then what was the hardest project you did?
The hardest project I'll do first, which was when I decided to learn how to use ROS, the robot, what does it stand for? Robot operating system, right, which has got multiple versions, overwhelming amounts of documentation, and it took me a year to work out how to make a robot navigate autonomously, and the videos did really badly because it's really niche. So that was probably the hardest. What was the other one? The best project? How much time do you have for how much time have we got?
We still have plenty of time.
So the best project's also the worst project. Right, so in 2008, a movie came out called Iron Man. And this is how I got started on YouTube. Basically, I was doing Iron Man builds and things like that. So I built an Iron Man suit. And I wasn't doing YouTube full time at the time, so it basically took me 4 years. And this is before I had a 3D printer. So all the parts were handmade, molded and cast. And I had 50 videos in my channel in the end. And I was still doing things along those lines. I built a Hulkbuster suit. I built some BB-8s. So I decided, like, what would be the most viral video I can put out? And I deliberately tried to make a viral video. So I got the 50 videos of Iron Man from 4 years and cut them into a 4-minute edit. And I made a really good thumbnail, and I put it on YouTube. And on every video I subsequently put out, I put that video on the end card. And then, basically, it went bonkers. So 6 years later, so I put it out in 2014. In 2020, it was still doing 500,000 or 1 million views a month. 6 years old. It had 70 or 80 million views. So, and I spoke to Mark Rober when he came over, and I said, have you ever had a video that's still doing 1 million views a month 6 years on? And he said he'd never had that. It was unheard of, you know. So the algorithm just grabbed it, and it kept feeding it to people, and people kept watching it, so it kept feeding it to people. But by then, I was doing autonomously navigating robots. I was doing ROS stuff and like PID controllers. So this video was still viral. 25% of people were still subscribing for this video, 1 million views a month. So the way the algorithm works is, if you watch a YouTube video and you don't subscribe, YouTube will still keep feeding you videos from that channel on your homepage for like the last 100 things you watched. So if you keep watching them, people think they're subscribed when they're not, right? Because it keeps feeding videos. So people, 1 million views a month on this video meant that 1 million people were getting fed my current content, which was completely unrelated by then, really. And that meant click-through was really bad, because they didn't click on the new videos, because it wasn't interesting. It wasn't an Iron Man build. It was something about like wheel odometry and publishing ROS topics. So basically, click-through was really bad on my videos. And also, if they did click on it, they didn't watch much of it. So retention was really bad. So basically, it killed all of my views. So it was my best project. Then it became the worst thing ever. So basically, I deleted 100 million views from my YouTube channel. So I deleted that video. Another one about a Hulkbuster helmet that had 9 million views. Another one with 2 million views. Basically, 100 million views went off my public view count. And then, so that was in September 2020. And then by January, so I was having maybe 30, 40,000 views on the videos, pushing 1 million subscribers. And then in January 2020, the first video I put out did 500,000 views, and it's gone up since then. If you look at the stats overall, though, it's completely flat, because even though I removed 1 million views a month, the videos, you know, the views went on my current videos, because people got suggested the current relevant content. So the overall view count is flat, but what happened was those views went on my new videos, which were longer videos with mid-rolls. The Iron Man video was viewed in like Mexico, Thailand, and Brazil, where advertising rates are really bad. The new ones were viewed in the USA, UK, Germany, so advertising rates are better. So the money went up, views stayed flat, and also brands who sponsor ad spots don't want to know about a video you did 6 years ago. They want to know about how many views you're going to get on a current video. So yeah, it became like the curse of going viral. The end.
Thank you. Any more questions? No other takers? Yes.
Are there any collaborations you're looking forward to doing at the moment, both either makers or with an industrial partner?
Yes, I've got, so the crash test dummy, I'm at this show talking to other makers about what we can do with a crash test dummy that I can't do, or at least I could do, but it'd probably get demonetized for being too dangerous. So that's one of the reasons I built that. So I've got this thing I can go around with and say, hey, what should we do? You want to do a human egg drop challenge? Let's not put a human in, let's use a crash test dummy. That sort of thing. Industries, I mean, I'm sponsored by multiple brands, so I suppose there's always collaborations. I don't know of anything coming up that's more involved than that. I've tried doing things with universities for students' final year projects, but they always turn out not to be quite as good as they should be, so I'm trying to avoid that. I think that's about it.
All right. I guess we got it then. Thank you so much, James, for another talk, all the info and the insights. Thank you. He's over here if you want to.